We assume that the past is a finished book. We believe the ink is dry, the pages turned, the events locked in the amber of history. We assume that when we look at a star, we are merely passive observers catching ancient light that traveled across the void long before we were born. We assume that reality exists out there, independent of us, solid and unyielding, waiting to be discovered. But there is a school of thought, born in the icy intellectual climate of the 1920s, in the mind of Niels Bohr and his colleagues in Copenhagen, that suggests this assumption is fundamentally wrong. They uncovered a mechanism in the fabric of the universe that implies something staggering, that the world does not exist in a definite state until we force it to. And even more terrifying, modern experiments suggest that our choices now, in this present moment, can ripple backwards, determining the history of a particle, effectively rewriting the past. This is the story of the Copenhagen Interpretation, the measurement problem, and the experiments that suggest reality is not a recording, but a live performance that responds to the audience. To understand this, we must first strip away the illusion of the clockwork universe. For centuries, physics was dominated by Isaac Newton. The universe was a machine. If you knew the position and speed of every particle in the universe at a single moment, you could, in theory, calculate their entire future and their entire past. History was a straight line. Cause always preceded effect. Then came the quantum revolution. It began when physicists started looking at the fundamental building blocks of matter, photons of light, electrons, atoms. They expected these tiny objects to behave like tiny rocks. If you throw a rock, it travels in a specific arc. It is always somewhere. But they found that matter does not behave like rocks. It behaves like a ghost. Consider the single most famous experiment in the history of physics, the double slit experiment. Imagine you have a wall with two vertical slits cut into it. Behind that wall is a detector screen. If you fire machine gun bullets at the slits, some will pass through the left slit, some through the right. On the back screen, you will get two bands of bullet marks. This is how particles behave. Now we shrink our machine gun. We fire electrons, tiny particles of matter. We fire them one by one. Logic dictates we should get two bands of electrons on the back screen, but we don't. We get an interference pattern, a series of alternating bright and dark stripes. This is the signature of a wave. Think of water ripples passing through two gates in a dam. The ripples overlap, creating peaks and troughs. This was the first shock. Matter, the stuff you and I are made of, is not solid. It exists as a wave of probability. An electron isn't here or there. It is a ghostly cloud of potential locations. But the Copenhagen physicists, led by Bohr, went further. They asked, if the electron is a wave passing through both slits at once to create that pattern, what happens if we look at it? What happens if we place a sensor at the slits to see which one the electron actually goes through? The moment you turn on the sensor, the moment you choose to measure the path, the interference pattern vanishes. The electron suddenly stops behaving like a wave. It snaps into a single, solid particle. It goes through only one slit. The pattern on the back screen becomes two simple bands. By merely watching, we changed the nature of reality. The universe knew we were looking. This is the observer effect. In the Copenhagen view, unmeasured reality exists in a superposition, a haze of all possible states at once. It is only when an observer or a measuring apparatus interacts with the system that the wave function collapses. We force the universe to choose. But this was only the beginning. The rabbit hole goes much deeper. If the act of measurement creates reality, what happens if we delay that measurement? What if we wait until after the event has supposedly happened to decide how we measure it? This brings us to the specific assertion that reality responds in reverse. This comes from a thought experiment proposed by John Archibald Wheeler, a giant of physics who worked with both Einstein and Bohr. He called it the delayed choice experiment. Wheeler asked, what if we let the photon pass through the double slits, but we don't decide whether to check which path it took until after it has already passed the slits, but before it hits the back screen? Common sense says the photon has already made its decision. It either went through one slit, as a particle, or both, as a wave, the moment it passed the wall. Our choice to look at it a nanosecond later shouldn't matter. The past is done. But when we perform this experiment in the lab and we have, using sophisticated lasers and mirrors, something impossible happens. If we choose, at the very last microsecond, to measure the path, the photon acts as if it had always been a particle. It arrives as a single lump. If we choose, at the last microsecond, not to measure the path, the photon acts as if it had always been a wave. It creates an interference pattern. Let that sink in. The photon has already passed the slits. It is in mid-flight. Yet, the decision we make now determines how it behaved then. It is as if the photon, sensing our future choice, reached back in time to the moment it was at the slits and adjusted its history to match our decision. The physicist interprets this not as magic, but as a breakdown of our concept of time and reality. Wheeler described this with the metaphor of the great smoky dragon. The tail of the dragon is the source of the photon. The mouth of the dragon is the detector where it bites, where we see it. But the body of the dragon, the space in between, the journey is made of smoke. It is undefined. It does not exist. There is no path the particle took. There is no history until the moment of arrival. The Copenhagen Interpretation asserts that we do not simply uncover the past, we generate it. By asking a specific question, did you go left or right? We force the universe to fabricate a history where it went left or right. If we ask a different question, did you behave like a wave? The universe fabricates a history where it waved. Reality is not a pre-existing stage. It is a response to the questions we ask. This leads to the even more advanced and mind-bending version of this phenomenon, the quantum eraser. In the quantum eraser experiment, we set up the double slit. We label the photons so we know which path they took, usually by entangling them with partner particles. Because we know the path, the interference pattern disappears. The universe shows us particles, but then we do something devious. We take that information, the which path data, and we destroy it. We erase it before we look at it. When we erase the knowledge of which path the particle took, the interference pattern reappears, even though the particle had already passed the slits as a particle because the detectors were on. The act of erasing the information later seems to retroactively restore its wave nature. It implies that reality is purely a function of information. If the information about the path exists, reality is a particle. If the information is destroyed, reality resets to a wave. The timing doesn't matter. The sequence of events doesn't matter. This challenges the very bedrock of causality. We are taught that the past dictates the present. But in the quantum realm, the present relationship between the observer and the information seems to dictate the past. Niels Bohr, the father of the Copenhagen Interpretation, famously argued with Einstein about this. Einstein hated it. He wanted a universe that was real whether he looked at it or not. He asked, "Do you really believe the moon is not there when you are not looking at it?" Bohr's response was essentially, the concept of the moon being there has no meaning outside of an observation. There is no deep reality. There is only the interaction. When we say Copenhagen physicists assert reality responds to human choices, we are speaking about the specific setup of the experiment. The choice is the configuration of the apparatus. But why is it phrased as human choice? This touches on the von Neumann-Wigner interpretation, a more radical offshoot. John von Neumann, one of the greatest mathematicians in history, analyzed the mathematics of the wave function. He realized that you can trace the chain of measurement from the particle, to the detector, to the wire, to the dial, to the human eye, to the human brain. But where does the collapse happen? The detector is made of atoms. It also follows quantum laws. The wire is made of atoms. The eye is made of atoms. Strictly speaking, the entire chain should remain in a superposition of possibilities. The dial should be pointing at both positions simultaneously until something outside the system collapses it. Von Neumann and Eugene Wigner suggested that the only thing arguably outside the physical laws of quantum mechanics is consciousness itself, the human mind. In this view, the universe remains in a suspended state of maybe a vast, overlapping ghost world until a conscious observer takes note. It implies that we are not passive witnesses to the universe, but active participants. We are the co-authors of reality. Without the observer, the universe is merely a potentiality. This brings us back to the reverse response. If our consciousness or our choice of measurement collapses the wave function, and if that collapse determines the history of the particle, then we are, in a very specific physical sense, influencing the past. This does not mean you can close your eyes and wish for the dinosaurs to be alive. Quantum mechanics operates on the microscale. though its implications are universal. The macroscopic world we live in is a messy aggregate of trillions of collapses happening constantly, but the fundamental principle remains. The history of the constituent parts of the universe is not fixed until interacted with. Consider the cosmic implications. Wheeler took his delayed choice experiment and applied it to the cosmos. He imagined a photon emitted by a quasar billions of light years away. This photon travels across the universe for billions of years. On its way to Earth, it encounters a massive galaxy. The gravity of the galaxy acts like a lens, bending the light. The photon can go around the left side of the galaxy or the right side. This is a cosmic double-slit experiment. Billions of years later, the photon arrives at Earth. We point our telescope at it. We can choose to measure which side of the galaxy it came from, particle behavior, or we can choose to combine the light to look for an interference pattern, wave behavior. According to the logic of the delayed choice experiment, our decision tonight determines whether that photon took a specific path around that galaxy billions of years ago, or whether it took both paths simultaneously. Our choice in the 21st century reaches back across the eons to resolve an event that happened before the Earth even existed. This is why the Copenhagen Interpretation is so disturbing. It shatters the glass separation between subject and object. It asserts that you cannot talk about nature without talking about the method of questioning nature. Let's go deeper into the mechanism of this response. How does the universe know? This leads to the concept of non-locality and entanglement. If two particles interact, they become entangled. They share a single wave function. If you measure one, the other responds instantly, no matter how far away it is. Einstein called this spooky action at a distance. He thought it proved quantum mechanics was incomplete. He argued that there must be hidden variables, secret instructions inside the particles that told them what to do, preserving the idea of a solid, independent reality. But in the 1960s, physicist John Bell formulated a way to test this, and subsequent experiments by Clauser, Aspect, and Zeilinger proved Einstein wrong. There are no hidden variables. The particles do not have secret instructions. They truly are undefined until the moment of measurement. This connects to the reverse idea because it shows that space and time are not fundamental barriers to quantum connection. If instant connection across space is possible non-locality, then the rigidity of connection across time is also questionable. The view that reality responds to human choices in reverse is a dramatic but accurate way of describing the participatory universe. It suggests that the universe is a feedback loop. We usually think of the Big Bang starting the universe, leading to stars, then planets, then life, then us. A one-way street. But if the observer is required to collapse the past into a definite history, then the universe might require the existence of observers at the end of time to give reality to the beginning of time. This is a loop. The universe creates the observer, and the observer crystallizes the universe. So when we look at the double-slit experiment or the quantum eraser, we are looking at the engine room of existence. We are seeing the raw code, and the code says that history is not a read-only file. It is a read-write file, and the write head is the act of measurement. To summarize the assertion in full detail. Superposition, matter exists in all possible states simultaneously. Collapse, measurement forces a choice, reducing possibility to actuality. Delayed choice, this choice can be made after the physical event has ostensibly finished. Retroactive definition, the late choice defines the early history. The particle becomes what we look for. This implies that the past is a theoretical construct derived from the present. As physicist Stephen Hawking once noted in relation to quantum cosmology, the universe does not have a single history, but every possible history. When we observe the universe, we are selecting one history out of the infinite library of potential histories. We are not merely walking through a museum of reality. We are painting the pictures as we walk past the empty frames. The Copenhagen physicists do not claim that we can use this to send messages back in time or change the winner of the last election. Response of reality is random in its outcome. We can choose to measure, but we cannot choose the result of the measurement, e.g., we can force the electron to pick a slit, but we can't force it to pick the left slit. This randomness protects the timeline from paradoxes. Nature allows the past to be fluid, but it prevents us from controlling it to our advantage. However, the philosophical weight remains. The rigid arrow of time, from past to future, is a macroscopic statistical illusion. At the fundamental level, the transaction between observer and observed transcends the linear flow of time. So, when you make a choice to look, to measure, to probe the depths of the atom, you are not just finding out what happened, you are defining what happened. You are reaching back into the shadow of the past and giving it form. The universe is a dialogue, and in the silence of the quantum vacuum, reality waits for you to speak first. This realization forces a terrifying humility. We are not small, insignificant specks in a giant, indifferent machine. We are the key to the machine. Without the measurement, without the choice, there is no song, only the silence of infinite potential. The Copenhagen assertion is that the world is not out there. It is right here, in the interaction. The track is laid down only as the train wheels touch the ground, and sometimes, looking out the back window changes where the train started. This is the quantum world. It does not make sense to our primate brains, evolved for throwing spears and climbing trees. But the math does not lie. The experiments do not lie. Reality is responsive. It is fluid. And in some profound, ghostly way, it is listening to us, waiting for us to choose so it can decide what it was all along.